Hey guys, this is going to be our 8th grade Chapter 5 review. I'm going to go through this pretty quickly as possible, so hopefully I don't leave anybody behind. If it's too confusing or you don't get something the first time, just watch the video again, go through it again. Maybe it'll make a little bit more sense. Alright, number one. So, well, first off, the review is based on writing linear equations from situations, graphs, in a table. So we're going to do it from graphs here. We're not going to do it from situations. We're just going to do it from graphs and two tables down here. Okay. So the very first thing you do is you always want to start with your y-intercept. The y-intercept is where the graph, where the line starts or goes through. In this situation, it's here, so we don't know if it starts here. We don't know if it just starts somewhere else, right? We just typically focus on the first quadrant. So in the first quadrant here, all we're dealing with is positive x's and positive y's. So for all we know, at this point, we just think, okay, it starts right here at 30. So 30 is going to be your y-intercept. So your y-intercept is always going to be at the end, just like that. Okay? So remember, the slope-intercept form is y equals mx plus b. The y-intercept is typically the first thing that's given to you. It's something that you can pretty much notice right off the bat. Okay? And then you're going to put that down first. Like right here, you see a number between 60 and 8. Well, that's got to be 70. So the 70 is going to be your y-intercept for this equation. So put plus 70, it's positive, so it's plus 70 at the end. Now, I'm going to put x here, put x here. Now we got to find out our slope. Now our slope, remember, it's rise over run. Rise over run. So let's see if I can do that. So this is rise over run. And rise always goes either up or down, and run always goes in one direction. It goes to the right. So you're going to set it up as a fraction. Rise goes on top and goes on the bottom. So if we pick any 2 points on this line, I'm going to start with this one because that's the most obvious point. I'm going to pick another one that falls right on x and y. I don't see one yet. Don't see one yet. I see one right here. So I'm going to pick this point right here. Okay. Now there is a slope form. Now we have not talked about slope form that much. We've talked about it a few times. We've gone through it a few times. Slope form is, the form for slope would be, instead of using rise over run, they say y2 minus y1 over x2 minus x1. Okay, that's going to be your slope. Now, you can do that. There's absolutely nothing wrong by doing that here. Okay? And if you wanted to do that, this would be what? 0, 30. This is 8. See, this goes up by 15. Okay, this goes up by 15. So this is going to be 75. So this is 8, 75. So if you want to do it this way, you plug in, so this is x1, y1. This is x2, y2. We just plug our numbers in. So we got 75 minus 30 over top of 8 minus 0, which would equal 45 over 8, and that's your slope, 45 over 8. Now, I don't do it that way. The way I do it, it's a little different. I think it's a little bit more efficient, but that's just me. I typically start at one point and go to the next, mainly because you have a graph, and you might as well utilize the graph to your benefit. Now, if all you've been given is 2 ordered pairs, and that's it, and then you have to figure out the equation based off those 2 ordered pairs, and you don't have the graph, then obviously you want to use the slope form to figure that out. Okay? So when I do it, I just do rise. So I go, okay, it's going to go up, and then it's going to go over. It goes from 30 to 75. Well, 30 to 75, it's going up, or you can say it's going up by 15, right? 15, 30, all right? So this is 15, 30, 45. So it goes up 45. And basically you're doing the same thing here. It goes up 45 because you're subtracting 75, which is up here, minus 30, which is down here. So 75 minus 30 is 45. That's going to be your rise. Your run, you're starting at 0. See? You start at 0 right here. You go to 8. That's plus 8. You're making a run of 8 units. That's where the 8 comes from. So again, I think, and again, there's nothing wrong with doing it this way. Okay? Nothing wrong with doing it this way. It's just a little bit more work, but you can do it. I like to count. I like to go up, I like to go down, and then over. Okay? So the slope here is going to be 45 over 8. You can write it as a decimal. You can, I'm going to just leave it like that. I think it's fine. Nothing wrong with that. Okay? A decimal, I think it's going to be, if I'm not mistaken, it's going to be 5.625 as a decimal, x plus 30. So this could also be your equation. Okay? All right, let's look at B. So starting point again is 70. I'm going to pick 2 points. I'm going to pick this point, and I'm going to pick this point. Those are probably the easiest 2 points to pick. If you start at 70 and you go down to 0, that's a drop of 70. If you go from 0 all the way to 3.5, that's a run of 3.5 or 3.5. So the rise is negative 70. The run is 3.5. You simplify it, or you divide the top by the bottom, because it can go unevenly, it's going to be negative 20. So it's going to be negative 20x plus 70. That's your equation. Okay, moving on. Number 2, write the equation for each linear relationship in slope-intercept form. All right, you always want to find your y-intercept first, and then move from there. Now, sometimes you're not given the y-intercept. Sometimes you are. In A, you're given the y-intercept. The intercept is right here. Whenever x is 0, right? Whenever x is like right here, if x is 0, whatever y is, that's your y-intercept. Okay? So here, if x is 0, the y-intercept is 2.1. So we know it's going to be 2.1. Okay? We just don't know what the slope is. But we know that the slope is rise over run. Or in other words, it's the change in y, the change in your y values over change in your x values. Okay? So change in y, well, let's take a look. What's the change in y? Well, it's changing by, well, that one's changing by 20. This is also changing by 20. This is also changing by 20. This is also changing by 20. So the change in the y values is 20. So you're adding 20 each time. So that's 20. That's your rise. Your run, well, this is an increase of 25. This is an increase of 25. This is an increase of 25. So you notice right off the bat, well, the run, you're increasing by 25 each time. So that's your slope. So if we could put that here for your slope, and that'd be fine. Most math teachers prefer to be simplified in simplest form. So if I divide the top and bottom by 5, I would get 4/5. So 4/5 would be your slope. Okay, or 0.8 on a decimal. Okay, that's it. Here, same thing. Now we don't have our y-intercept. Okay, it's not given to us, so that's something we have to dig for a little bit. Let's just go ahead and do the slope first. So the slope, let's see, our rise is negative 4, minus 4, minus 4, minus 4, minus 4. So negative 4 is your rise. Your run, you're increasing by 15 each time. So your run is 15. So right off the bat, the slope is negative 4 over 15. X plus, again, we don't know what our y-intercept is. So for this one, what you could do is go backwards. So here we didn't have to go backwards because we already had the 0. But if I want to go from 30 and go all the way back to 0 to figure out what it is, then we can do that. If we added 15 each time to go in this direction, then just subtract 15 when you go in this direction. Keep subtracting by 15 until you get to 0. If we move 2 more times, so 30 minus 15 is 15, so that would be 15 if there was nothing here. This would be 15. And then 15 minus 15 is 0. So we just have to move back twice. So here, if we're subtracting 4 each time, that means if I want to go this way, I'm going to have to add 4. So 36 plus 4 is 40, so this would be 40. And then 40 plus 4 would be 44. So it should be 44. That's your y-intercept. Now you might ask, well, I don't know, that's a little bit too much for me. I don't know if I can do that. Well, you don't have to do that. You can do it another way. You just simply take your y equals negative 4/15 x plus b and plug in one of your ordered pairs. So if I plug in an ordered pair, let's say I pick this one here. Okay. So let's say I plug that ordered pair in here into that equation. And we're solving for b. So 90 is x, 20 is y, and then I just basically write everything else in. Negative 4/15 times 90 plus b. Okay? So if I go ahead and solve this, right? This would be what? 1, 6, negative 24 plus b equals 20. This is a one-step equation. I add 24 to both sides to get rid of that here. And b equals 44. And that is my y-intercept. Okay? So that's another way of finding your y-intercept. All right, moving on to the last page. This is behind. This is our page behind. This one, I'm just not using this one because it leads through. It's quite ugly, so I had to use another sheet of paper. All right, so for this one, you can make a line. You can try to find the slope. Really, all you need are 2 points. So now, for some students like the line, and I have no problem with the line. There's nothing wrong with the line. But sometimes if you draw the line a little bit off, sometimes you can get the y-intercept wrong. Sometimes. Okay? And then we're going to draw the line here. And my protractor is not perfect here. It's a little off. Okay. So same thing. You want to find. Actually, let's do our slope first, just to make sure we got it right. So I think if we got this as 10, 20, 30, 40, 50, 60, 70, 80, 90. So it could be 90. The y-intercept could be 90. On this one, 10, 20. So it's a little bit more than 10, maybe 12, 13, 14, somewhere in there. Maybe 11. I don't know. Somewhere around there. So we don't really know the y-intercept on this one. So what I would do is I would pick 2 points that's easy to read. I would pick definitely this one because we definitely know what this is, and let's pick the next one. Why not? Okay, that one's easy to read. So it goes from 70 and it drops down to 50. So if it goes from 70 to 50, that means it dropped down 20, right? So your rise is negative 20 because it dropped down 20. Then and it went over 1 block. Well, 1 block is worth 0, 10, 20, it's worth 10. So that's the run. Well, negative 20 divided by 2, negative 20 divided by 10 is 2, negative 2. That's your slope. So it's going to be y equals negative 2x. Now we find out our y-intercept. Now our y-intercept, I think it's 90, okay? So I'll plug it in there for right now. And let's test it. Let's make sure this is the correct equation. How can you check it? Pick another ordered pair. Let's pick this one. This is 40, 10. Right? This is 40, 10. That's the coordinates for this ordered pair. Plug in. So if I plug this in here, so negative 2 times x, which is 40, would be negative 80. Negative 80 plus 90 is 10. Well, guess what? Y is 10. That is 10. That works. So this is your equation. All right, let's go to this one. This one's a little bit harder. Just a little bit. Let's pick two ordered pairs that's easy to read, like that one. This one goes up from 20 to 30, right? So it goes up 10. And then it goes over from 30 to 70. So from 30 to 70, it's going to the right 40 total. Yeah, 40. So rise, over, run. So that means in lowest terms it's 1/4. So the equation is y equals 1/4 x plus, and you know, again, not sure because it's slightly above 10. Okay, it's not 10. I mean, you could guess maybe 10, but we want this to be accurate. So let's pick an ordered pair that we can plug into here and find out. So I'm going to do this down here just so because I have more space down here. And we'll put down B because we don't know what B is right now. So I'm going to pick an ordered pair. I'm going to pick, let's pick an easy one. Let's not make it too difficult. Let's do 30, 20. All right, let's do 30, 20. Let's plug that in. So 30 is your X, 20 is your Y. So 1/4 times 30 plus B. Well, if you do 1/4 of 30, which basically means 30 divided by 4 is what that means. That's what, 7.5? 7.5 plus B equals 20. Now we solve it like a one-step equation. We subtract 7.5 from both sides. This cancels out. We get 12.5. We get B over here. Our y-intercept is 12.5. So it's close. It was a little bit above the 10. So it's 12.5, and that's it. All right. Now, last but not least, it says, give an example of a real-world situation that can be represented by a linear relationship. My favorite one, as you know, is going to the fair. I don't know why that's stuck in my brain. We can do bowling. Bowling works too. All right, but I like the fair better. So it would be going to the fair. And paying $10 admission plus, let's say $3 per ticket for rides. Okay, this would be a typical linear equation because $3 per ticket for rides. Well, X will be the number of rides, right? Y would represent the total cost of going to the fair. So it will be Y equals 3X plus 10. Okay? Anyways, that's just an example. You can use just about anything in the world that has a one-time charge with some type of charge that is, you know, consistent. Like, I don't know, like how many games of bowling you want to do, how many rides you want to have, things of that nature. So, anyways, I hope that helps, guys. God bless, and I'll talk to you guys later.